Thanks everybody for joining us today. As you said, we're part of the, I think our official name is the Environmental Impacts Team, Task 3.1. And I know part of the reason for this today is that a lot of you, I understand, are interested in learning more about what we do and perhaps joining us in the field some this summer at various field sites that we're considering doing for the RET program. So we want to give you an opportunity to look at what we're doing and see if there's something that interests you that might be an opportunity for you to come out and join us, because we'd love to have you. But I want to start with sort of just to remind everybody, in case you're not a full-time BANRite, sort of what BANR is all about. I put this up because it's just illustrative of how big a team this is, and this is just sort of the project directors at all the institutions. This does not include all of the students, grad students, postdocs that are a part of this project. It's really big, and you can see the broad representation from different universities and units around the country. One change we've had on one of the feedstock teams is Woody Chung, who was previously at the University of Montana, is now at Oregon State. So we've extended our academic family just a little bit to Oregon State. But anyway, a big bunch of people working on this project. So, again, the background for this, the impetus for USDA putting out the request for this proposal was that looking at the beetle infestation in the Rocky Mountain region, it's probably unprecedented in size and extent and duration, and 42 million acres or thereabouts in the United States impacted by these bark beetles, and over half of that is in the four-state area of Colorado, Idaho, Montana, and Wyoming. And so this provides a great place to study this phenomenon. Of course, it's not over. The mountain pine beetle outbreaks are in some places locally beginning to die off, but there's an upturn in spruce beetle activity. So, this is not a phenomenon that's going away anytime soon. So there's the result of all this, that there's several hundred millions of tons of dead wood that are potential biofuel feedstock source, and that's one of the things we're looking into. So right now there's already removal of some of that for a variety of reasons. One of those is to reduce the risk of catastrophic wildfire, and there's a large contingency of people who believe that's a good thing to be doing. A lot of the agencies, particularly Forest Service, they're not doing as much of that right now as they are what they call hazard tree removal, which is trying to enhance safety for roads and trails and structures, campgrounds. Power lines is an important one because, as you can see in that photograph there, you can have a power line corridor, and even if you don't have a lightning strike that causes a fire, if a dead tree falls across that wire, you could have a fire that starts. So, and then also removing some of the wood might enhance regeneration, might enhance biodiversity or plant species diversity. It can change the habitat and improve habitat for a variety of organisms. But, wood from thinning and removing some of this stuff that they're doing in places is in a lot of places got a disposal problem. I don't know if you've driven through Summit County in Colorado. You can see from the interstate large piles of this wood where it's been dead for a few years. Maybe it was already on the ground, and they're getting it out of there. But once it reaches a certain age and decay stage and condition, it's no longer marketable for dimensional lumber or maybe even for pellets. So it's a disposal problem. So kind of got USDA thinking about maybe there are some other potential uses for that. So they began to ask the question: can we use this beetle kill and related wood, waste wood as a viable biofuel feedstock? And there's lots of opportunities. There's a lot of it there that's potentially available. It's really no displacement of productive land, so it doesn't, compete with things like sorghum or some of the other non-woody biomass fuels that are being grown that might be, replacing or displacing other agricultural crops. We think there might be minimal competing uses for other wood products, so the stuff that's going out for dimensional lumber will probably continue to go out, and this may be an additional source of feedstock. By taking this out, as I showed in the previous slide, this could be synergistic with some other objectives for fuels mitigation or forest restoration. And we think we can perhaps leverage this existing forest infrastructure in a lot of different areas and places that normally wouldn't see this kind of activity go on. So lots of opportunities, but along with that are a lot of challenges. Some of this, the accessibility of some of these areas is pretty constrained. You know, there's not necessarily roads to all these places. The topography may be steep or inaccessible. A large part of this area is in federally owned forests, and as I'll get into a little bit later here, that's not a problem for removal, although you know any kind of federal land or federal project requires invokes the NEPA process, so that puts up a bit of a barrier, or could. So there's policy issues, there are alternative use issues that, especially on the federal lands, maybe less so on the state lands depending on the state. The challenge for this too is if we're thinking about developing a biofuel industry, so to speak, you know, the feedstock creation is unmanaged, so we can't, at least in the Intermountain West, we're not looking to grow plantations of wood as a continuous supply. So it's episodic, it's patchy, although we do, as I said before, we think it's going to be ongoing for a while. And we've also kind of toyed around with the idea of if this proves to be a viable use of some of this, perhaps, you know, another way of thinking of this is not just post-beetle, but post-fire salvage as well. So it may be that the feedstock is not as episodic and patchy as we may think. And then, of course, there's the thing that our team's interested in is the potential for adverse environmental impacts. It could be, you know, soil erosion, either from removing the materials or from the machinery or things like that, reduced tree regeneration and productivity on the sites. The erosion could influence water quality. So there's opportunities and challenges here within the big project. So, you know, what we want to do, what the BANR project is trying to do is provide science-based underpinnings. And we're going to do a lot of research, and then the education team and the extension teams working to support the development of a sustainable biofuel production from beetle kill and other waste wood feedstocks. So here's for the project task overview, and there's let me back up just a minute here. There's lots of different areas. The two boxes in the top are the feedstock supply and logistics folks, and they're interested in how much is out there in this 4-state region. The logistics people, how can we get to it? How hard is it to get out? What are the costs and the processing to get it out of there? And then the middle box there is assisted performance and sustainability, which is we come into the play there with the field scale impact analysis, and then there's the ecosystem modeling and life cycle assessment folks, socioeconomic policy and decision support, and then the education and extension is a huge part of this. So those three bottom boxes are really going to be interacting a lot throughout this whole project, and we're starting to do that more and more now, as evidenced by this webinar. But we're the middle team here, the system performance and sustainability, and that's what we're going to talk about today. Particularly, we're task 3.1, and here are the major players right now. Chuck Rhodes is a U.S. Forest Service researcher down at Fort Collins. Elder Paul and Monique Roca are from Colorado State University. Paul and Sharon and I are all here at UW, and then the newest member of our team is Bethany Avera. She's a new PhD student down there. So there's a lot of undergraduates that are going to be working with us this summer in the field. So you know the team's going to grow at least for the summer, and then we expect that we'll be having a lot of those undergraduate students working with us both here and at CSU in the coming academic year as well to help with data processing, data entry, analysis, things like that. And what we're trying to do, we're trying to quantify, our objective is to quantify the ecological impacts of harvesting these trees and the different dominant forest types in the Rockies. Right now there's sort of a, you know, in this part of the world, at least where we are down here and at CSU, and to some degree in Montana, you know, lodgepole pine has been the dominant player. Mountain pine beetle is probably the most pervasive of the 4 major destructive beetles that are out there. And we have a lot of lodgepole pine forests in those 3 states. Idaho has lodgepole pine as well, but there's a lot more mixed conifer stands up there, more spruce, and so we're trying to understand where all the dominant forest types are, and what are the levels of infestation and damage and mortality in those areas to try to characterize what the ecological impacts might be from harvesting trees in those different forest types. And so the big picture thing that we're trying to do for our research, at least right now, is we're trying to put up paired study sites. So we go into an area and we'll locate a pair of study sites in stands that shouldn't be recently harvested, that should be planned harvested with 2 different harvest techniques. So it's one technique is called whole tree harvest, where they just cut the tree off and they take the whole thing from the site, all the branches, all the foliage, needles, everything off to a landing somewhere, process at the landing, and then take the lumber off. And in contrast to that is a lop and scatter technique, where they knock the trees down at the site, cut off all the non-merchantable side material, so all the smaller branches, all the leaves, needles, and everything, and leave them on the site. So in terms of site conditions and potential impacts on things like tree regeneration and understory plants and things like that, it's going to be very, very different. So we're trying to find areas where planned harvest is going to happen, and so we were going in and evaluating those stands, characterizing them in terms of their stand structure and productivity, and then they'll come in and harvest those stands, and we'll come back later and get a post-harvest assessment of what the impacts of those harvests have actually been. And then we're also looking at recently harvested and unharvested, and trying to compare between those two post-outbreak forests. And another question that we sort of have recently come up with, that we're toying around with, is the idea of something called a chronosequence. And if you're not familiar with that, if you think about chronosequences are often used in forest studies, particularly to understand how stands develop over time. And if you think about, if you go out into the woods and you pick a stand, and it's a very young stand, and you wonder, how does this stand develop? Or you go look at an older stand and you say, how has this stand developed? Well, there's a couple of ways you can understand that. One is to go into the young stand and begin to set up a study and go take measurements every 2 years or 5 years for 100 years. Well, obviously that's not very practical. So we use what's called a chronosequence approach sometimes. And so chronosequence, time sequence, and it's a substitution of space for time. And what that means is, if you want to know how a stand develops, you would look at a 2-year-old stand, and then a nearby 10-year-old stand, and maybe a nearby 25-year-old stand, an 80-year-old stand, a 150-year-old stand. And if the conditions have been similar throughout that time period, you can make assumptions about how a stand develops. Well, we're interested in how time influences what the potential impacts of this harvesting might be. So if we're sampling these stands and measuring the impact of harvesting a year after harvest, is that different than if we went into a stand 5 years after harvest or 10 years after harvest? So has some recovery occurred that we wouldn't pick up if we go in just the year after a harvest? Similarly, if you go in at the peak of a beetle outbreak, and around here the peak in lodgepole pine was around 2009, would the impacts of harvesting something like that be different than if you went into a stand where the beetles maybe still be active? So the time since the beetles were active. So there's a couple of time for space substitutions that we're playing around with that we may do some tests on this summer in some of our field work that we're going to be conducting. So what do we do when we're out there in these fields? What do we measure? We measure a lot of different things. We measure the density of live and dead trees. So how many dead trees are there per acre? How many live trees are there? What are the species? So what's the relative amounts of live and dead trees? We're very interested in understory trees, and this is something that we refer to as advanced regeneration, and this is really, really, to me, one of the really important things about our study, because unlike fire, let's say if you have a big fire in a lodgepole pine stand, the fire will pretty much consume and kill almost all the trees in a stand. It'll consume most everything in the understory, even sometimes all the way down to bare mineral soil. And so that stand sort of has to start from scratch, and any regeneration that occurs will have to happen, through brand new seedling establishment. Bark beetles are different in that they don't kill all the trees in the stand, and they usually don't kill all the small, fast-growing trees. And so, depending on the harvest techniques that are used and what the impacts are, that advanced regeneration could really give a kickstart to the next stand that's going to be developing on that site. So we're really interested in what those understory trees are doing and how the harvesting may impact that. We're interested in surface fuels in terms of how those fuels from the different harvesting techniques might influence fire behavior, and that's something that Paul's going to be talking about here in a few minutes. That's going to be a focus of his master's work here. And that surface fuel, just all the fuels information is going to not only inform Paul's project, but there are a couple of people who are going to be interested in doing some simulation modeling of stand development, following harvest, following no harvest, or following fire in harvested or non-harvested stands, and see what that does to carbon budgeting. You know, carbon emissions and carbon storage is an important topic in conservation and ecosystems these days, especially in forests. So that data is going to help inform some of those modeling efforts that we're going to be doing all the way down to the life cycle assessment, folks. We're interested in above ground net primary productivity. So how much carbon are these stands storing on an annual basis, and how do these harvesting techniques and harvest impacts influence the amount of carbon that these stands are taking up? We're interested in how the management techniques might influence soil properties. How much organic matter is still there? What is it going to do to nutrient dynamics? Because this is where, you know, all the plants for future forests and current forests are going to get their nutrients for growth. So are there any adverse impacts from the harvesting on soil properties? And then biodiversity is always something we're thinking about. Is it changing plant species diversity in terms of numbers of plants? Is it changing diversity in terms of composition of the community? Are we seeing more invasive species, for example? Are they replacing native plant species in there as a result of this disturbance of the soil and site? So those are some of the things that we're going to be monitoring. And so we're trying to be sure through this monitoring that we're going to that forest structural and functional characteristics are sustained or enhanced. And a lot of the forests around here, particularly lodgepole, you know, following fire or following beetle outbreaks, they're fairly resilient. They're adapted to these disturbances, and they can maintain forest structure and function over a long period of time, even if you leave them alone. But it's less clear what happens when you to those structural characteristics and functional characteristics if you go in and manipulate the stands. And so we're not really thinking about a lot of restoration necessarily. And that was one of the questions that when we visited the funders in Washington D.C. when we were defending our proposal, they said, "Well, what's your idea on restoration?" And you know, replanting and restoration is not a big operation in this part of the world. It's much more important in Pacific Northwest, for example, or southeastern U.S., but not really in the Intermountain West. So we want to see what the resilience of some of these stands are. So some updates on what we've been doing. One of the things you may be aware of this is that the whole project's trying to do, not just our task team, is trying to come up with a set of sites scattered regionally across the 4 states that are going to be useful for all of the teams to use, not just our team or not just the feedstock amounts and logistics teams, but the education folks, the socioeconomic analysis, policy analysis folks, the outreach people. So where are some common sites that satisfy everybody's requirements for their questions that they're asking for this project? And so we've identified 3 regional sites. One is the Colorado State Forest in northern Colorado. We've started a little work down there. I'll tell you about that in a second. The other one is up near the Helmand National Forest near Missoula in the Lubric Experimental Forest, which is just east of Missoula, Montana. And the third site is up in the Riggins and Grangeville area in Idaho. I've got some maps coming up here in just a second. I'll show you where those are. Right now, for field studies that are started, we've been working in conjunction with the 2 other feedstock teams, and we began last summer and fall 2014 in the Colorado State Forest down near Walden. And we collected data on 5 of those paired plots that I told you about, whole tree and loft and scatter pairs. And the plan was for all 5 of those to be harvested this winter. They do winter harvesting down here because they can get in there with 2 or 3 feet of snow, and it minimizes actually the impacts of the site. But they only got to do 2 of those harvests this winter. The weather was so mild, they'd reduced snowpack, so they called off the harvesting activities, Paul, March 11th or something like that. It was probably a month before they had planned to. So we're sort of regrouping and redefining what we're going to do. This is a 5-year project, So we can certainly do some more sampling this year, and with the hope that they'll be doing some harvesting in next coming winter. So all is not lost, but it was a little bit of a setback for us there. But that we've actually got started. What we're planning, we're still in the site selection process in terms of identifying specific field sites. So we have these regional areas where we know we're going to be working, or we think we're going to be working, but we haven't identified specific sites. And so 3 of us from our team are heading up to Montana and Idaho next week, meeting with some BANR folks, Peter Kolb and Rob Keefe specifically, and we're going to begin to try to identify specific sites that we'll use this coming summer to continue the kinds of sampling that I've described for you already. So right now, I can't tell you exactly when we'll be going there, and Paul's got some more exact dates for Colorado. The plan is to start our sampling this summer in Colorado in June, and so in late June and July and probably early August is when we'll be moving up into Montana and Idaho to continue and start field sampling up there based on the model we've started creating down here in Colorado. We're going to design and implement some more intensive study sites, like I say, in Idaho and Montana. We're anticipating a full field season, and we're going to try to integrate with some of the other task groups, particularly 1 and 2.1, the feedstock logistics folks. And then we're beginning to use some of the data we got from last summer, and some we'll be getting from this summer, to begin to finalize our questions and modeling approaches. That Sharon Martinson, the postdoc here at Wyoming, is going to be doing a lot of the simulation modeling of carbon and fire dynamics, and looking at differences in the different treatments, looking at differences in treated and untreated stands. Again, what happens if you don't treat a stand? How are the carbon pools changed versus if you treat the stand? What happens to fire behavior or fire risk, for example, if you treat a stand or if you don't? And if that stand burns, how does that change what the carbon is doing in the stand? So those are all things that they're working on right now, and we're looking forward to a good field season coming up here. Here's just a Google map. You can see Missoula sort of in the left central area. This is up in Montana. There's a box that approximates where the Lubrecht Experimental Forest is, and then north and kind of east of there is the Helena National Forest. So that's where we'll be next week, looking at potential sites in Montana. And then this is the Idaho area. The blue oval there is the Slate Creek timber sale. That's on U.S. Forest Service land. It's several harvests have already been done. Many, many more are planned in that area. There's a lot of state forest in this area. The little A thumbtack down there is Riggins, Idaho, and then if you move on up to the north of that blue area, you see Grangeville. And so that's sort of the region. It's a big region, but that's the area that we're thinking of for field efforts for this coming year. So that kind of tells you the overview of what we're doing, what we plan, what we have done, and what we hope to get done this summer. I think there's the potential for folks to join us in the field at any of those 3 places. I wish we had exact dates for when we're going to be at Slate Creek, when we're going to be in the Helena or in Lubrecht in Montana, but we don't. July is going to be a safe bet. We're going to be one of those places in July and probably into early August as well. So I think at this point I'm going to turn it on over to Paul, and he's going to tell you about some work that's going to be going on this summer down in the Colorado State Forest that he's working on. And this might be for those of you who are close by, or even if you're not, it might be a good chance for you to join in on some field work down there.
Hello, everyone. Again, my name is Paul, and I'm a master's student working under Dan Tinker and ultimately under the BANR project. In addressing the ecological impacts associated with these harvests, we thought it would be crucial to understand the impacts that these harvests would have on wildfire behavior. So ultimately, we're looking to quantify how harvests will impact factors associated with wildfire. Sort of do this in 2 different ways. First, we're looking to analyze the differences in fuel load between mountain pine bark beetle infested lodgepole pine harvested plots and adjacent untreated plots with the same forest structure as the pre-harvest. So harvested plots versus untreated plots. As well as we're looking specifically at the changes in fuel moisture between untreated and the 2 treatment types. So as Dan mentioned, lop and scatter and whole treatment extraction, which are 2 common methods of harvest throughout the Intermountain West. So just to make sure we're all on the same page here, I wanted to go over a few concepts associated with fuels and fire behavior. So there's the wildfire behavior triangle. On one aspect, you have topography, which sort of refers to the steepness of a slope and the aspect, whether it's north or south facing, as well as weather, which can be in terms of wind or the relative humidity in the air. And then finally, we have fuels, and we sort of have three groups of fuels. The first group, it would be aerial fuels, which refers to the green and dead materials in the upper forest canopy. These are the branches or snags, which are dead standing trees, moss, and even high brush. We also have surface fuels, which are needles or leaves, duff, grass, and herbaceous material, small dead wood, downed logs, stumps, and even reproduction or small seedlings growing up of trees. And last, we have ground fuels. Those are the fuels lying beneath the soil. It's the duff or roots or rotten buried logs. So with these fuel groups, we have fuel characteristics associated with each of them. Fuel loading refers to the oven dry weight of fuels in a given area. So for example, a grassland generally has a fuel load of approximately 1 to 5 tons per acre, where logging slash can vary between 30 and 200 tons per acre, and a timber stand can also vary between 100 and 600 tons per acre. You have different size and shapes in your fuels. Compactedness, referring to the spacing between fuel particles. Horizontal continuity, how fuels are spread across the landscape, whether they're spread evenly, which might promote fast spread of fire, or heterogeneous, where there's sort of breaks between the fuels. Vertical arrangement, the relative heights of fuels above ground and their vertical continuity. This sort of refers to the concept of ladder fuels, or how easily fire can travel from sort of the surface and up into trees, causing torching of one tree, or crowning where multiple trees are on fire. Then we have fuel moisture content, which I'll be looking into extensively, but the amount of water and fuels expressed as a percent of the oven dry weight. Oven dry weight refers to taking a fuel from out in the field, bring it back into the lab, and drying it too, so there's no moisture left in it. Finally, we have the chemical properties. These are the presence of volatile substances such as oil, resin, wax, and pitch and fuels that affect the rate of combustion. So, moving on. Specifically, how are we going to relate this to the BANR objectives? We want to look at the impacts associated with harvest and mountain pine bark beetle infested stands on wildfire behavior. In particular, we want to look at how the change in fuel load will affect this, as well as how change in abiotic factors, or those the non-living chemical or physical parts of the environment, how those will affect fuel moisture, and abiotic variables being solar radiation, wind, temperature, relative humidity, and soil moisture. Furthermore, we want to know what the impacts will be based on harvest method. Again, lap and scatter versus whole tree extraction. So, as Dan mentioned, my study area is in the Colorado State Forest. This is, as you can see on the inset map in the upper right-hand corner, sort of near the Colorado-Wyoming border in north-central Colorado. This area is dominated by mature lodgepole pine stands with mixed spruce and fir species. It has seen widespread mortality from the mountain pine bark beetle. The activity began there between 1998 and 2002. The stands that I'll be working in particular see a greater than 50% mortality in the trees. In 2009, salvage logging to remove overstory pines started here. As you can see, those yellowish polygons are sort of treatments set out by the state forest, and it's hard to see, but there's a cross-hatched red pattern in some of those. Those are the treatments that have actually been completed. Furthermore, you can see the sort of red paired dots. These are the paired plots that Dan had referred to earlier in the fall of 2014, we sampled all of these, and we'll be headed back there again this summer to resample the 2 paired plots that were actually harvested. So, in particular with the fuel load questions, how does fuel load structure and density change as a result of harvest? And how does fuel load structure vary between harvest type in terms of lap and scatter and whole treatment? My hypotheses are that the dominant fuel load structure will change from dead and standing to exclusively surface fuels. Furthermore, lap and scatter will greatly increase surface fuels, where whole tree extraction will reduce the potential for surface and crown fires. As you can see in this picture down here, this is actually one of those paired plots that was harvested this winter. On the right-hand side here, you have whole tree extraction. You can see that there's minimal to no surface fuels left, where on the left-hand side you have the lap and scatter, where you can see there's significant surface fuels. And the top picture is what it looked like before it was harvested. So again, pre and post, we harvested all the plots in 2014. 2 of them were harvested this winter. We'll head back there in June to resample those plots. Additionally, we'll be adding more untreated versus treated plots. So in those yellow polygons that we saw on the first map, some of those areas were additionally harvested this winter, and we'll go there and set up treated plots and then find close plots in untreated areas that are representative of the forest type, and sort of set up an untreated versus treated study there. So at each of these plots, we have sort of an extensive 30 by 30 meter plot layout. In each of these plots, we measure all of the trees in one quadrant. To measure the trees, we use an inclinometer, which uses trigonometry to get the tree height. So we measure our distance from the tree, and then we use the inclinometer to get the angle to the bottom of the tree, and then the angle to the top of the tree, and we can get the tree height from that. Additionally, not mentioned here is we'll take the DBH of every tree in the entire plot, and that ultimately refers the diameter at breast height, and is universally 1.37 meters high. In terms of tree heights, we'll also get the height of compact crown. This refers to the height at which the sum of live branches equals a full whorl, and ultimately sort of tells us where the compact crown starts. Additionally, we'll get the crown base height, which is the height to the lowest live branch. Both of these measurements allow us to understand the ladder fuels aspect of this, or how easily fire can move from the surface up into the canopy. And if you have a low crown base height, there's better potential for fire to move up the tree and either torch or start crowning a stand. Additionally, we'll be taking tree cores. This allows us to get a sample of the inside of a tree and look at the tree rings to determine the age, as well as the distance between the rings will tell us the growth rate of the tree. And last, we'll look at the tops of the trees and determine cone serotiny. Lodgepole pines have serotinous cones, or can have serotinous cones, which are closed cones that are sort of binded together by a waxy material. And this waxy material holds them shut until excessive heat promotes the deterioration of the waxy layer and ultimately opens these cones. So looking at cone serotiny, we can look at the seed bank in a particular forest, and if there's a lot of serotinous cones, we would say that it has a higher seed bank. Furthermore, we'll be looking at surface fuels or coarse wood fuels. Each of these are divided up into fuel classes, as you can see, and the 1 hour, 10 hour, 100 hour, 1,000 hour refers to the time lag to change in fuel moisture. So as you could imagine, the 1 hour fuels are very small diameter, and in fact they're less than a 1/4 inch diameter, and so they would take minimal time to have a change in fuel moisture. The 1,000 hour fuels are greater than 3 inches and take a much longer time to have a change in fuel moisture. As you can see in the bottom right picture, we're measuring those with a caliper, and that to me looks like maybe a 100-hour fuel, so between 1 inch and 3 inches. And you can see the measuring tape. That's a coarse wood transect. We have sort of 10 of those, 5 starting from the west side and 5 coming across the east side. And those are 20-meter transects where we gather coarse wood and surface wood measurements. Furthermore, we look at the litter, which is the freshly decomposed or recognizable fuel particles on the surface, and then duff, which is generally just under the litter, and these are the decomposed or unrecognizable fragments. And then finally, we'll measure the fuel bed, which is the top of the litter to the top of herbaceous material or coarse wood, and I'm taking those measurements along the transects there. So as you can see with this plot layout, we get a very thorough examination of the fuels in each plot. So moving on to fuel moisture. The questions associated with fuel moisture are: how does fuel moisture vary between untreated and harvested plots? Additionally, how will these changes vary between harvest type in terms of lap and scatter and whole tree? How do abiotic variables differ between untreated and both harvested sites? And then in particular, how do these differences in abiotic variables affect fuel moisture? So the hypothesis being that fuel moisture will decrease at a faster rate in harvested areas because of more sun, lower relative humidity, increased wind, increased temperature as there's no shading from an upper canopy. And then finally, the fuel moisture will be generally less, or the percent dry weight will be less in treated areas than in untreated. So I have a little animation here. As you can see, in the back is an untreated area, and in the foreground is a treated area. If wind comes through, you can see it sort of gets hung up in the canopy of trees and doesn't really affect the surface fuels, where in a treated area, you can see the wind sort of scours across it, and in a low humidity area could dry out those fuels quite quickly. Additionally, you can see there's a higher amount of incoming solar radiation, which you could see would likely not have much of an effect on the surface fuels in the untreated areas, but in the treated areas, you can see that it pulls the moisture out of the fuels that are there, presumably making them much drier. So how will we measure all of this? We're going to have fuel moisture stations in all of the plots. A fuel moisture station will consist of a 1-hour fuel, a 10-hour fuel, a 100-hour fuel, and a 1,000-hour fuel. And I will go to each of these stations weekly and measure them to document the percent loss. And then finally, at the end of the summer, I'll bring all of those fuel particles into the lab and measure them to get their dry weight. Additionally, we are in the process of building weather stations. In our weather stations, we'll have an anemometer that it gauges the wind, a pyranometer, which is measures solar radiation. We'll measure temperature, relative humidity, and then we'll have a probe under the litter layer that measures soil moisture. In terms of this summer's field work, in May, I'll be headed out to the Colorado State Forest to scout for those additional untreated and treated plots, as well as create my fuel moisture stations and then set up all of those weather stations. In June, we'll begin a much larger effort of resampling those harvested plots and then sample new untreated versus treated plots. This will provide a good opportunity for teachers to come out. In particular, the week of June 8th would be an excellent opportunity for teachers to come out. We'll be staying in these yurts in the Colorado State Forest. They come with a propane cook stove and bedding for approximately 6, but we can put tents out, or depending on how many people come out, we could rent additional yurts. And then from there, mostly myself, I'll be remaining there and just measuring the fuel moisture loss at the fuel moisture stations, and the rest of the crew will head out to Montana and Idaho to survey those sites that Dan talked about. So we'd love to have you out there. It'd be great to have additional help, and thanks.
So I think that's what we have for you today. Does anybody have questions about where we're going, what we're doing, when we're going, what would be involved if you came and joined us? logistics, anything? So let's see, remediation and replanting is not a common practice out here because it's not needed. If you're referring to a lot of the forests of the Intermountain West, Logan, yes, that's correct. You know, most of the well, if you think about lodgepole pine, which is one of the dominant forest types out here, those forests have evolved with fire, with large stand replacing fire. They've evolved with bark beetles. The bark beetles have been around a lot longer than we have, and so, you know, we've had forests on these landscapes since the end of the Pleistocene, when the glaciers melted, and then for millions of years prior to that. So, you know, as Paul mentioned, the serotinous cones that lodgepole has is a great fire adaptation, and so as you know, we typically get great natural regeneration. And interestingly, you know, a lot of the folks in the Forest Service, they're certainly well aware of those cones, and they use those serotinous cones as a regeneration technique. They can go into a site and clear cut it and leave 2 or 3 trees standing that have serotinous cones, and because you've opened up the site, opened up the canopy, or maybe even the forest floor, and scattered those cones around, there's enough heat from the sun that it'll actually open those cones. And you know, a lot of the work that I've done over here in the Medicine Bow, following clear cuts, the regeneration following a fire, following clear cuts, is so dense that if the Forest Service is managing that for a timber stand, they'll have to go in and do maybe 2 pre-commercial thinnings, because it regenerates so well, you know, beyond what the Forest Service might be looking for. And in more of a natural setting like Yellowstone, which is another place that I do a lot of work, some of those post-fire stands up there that regenerated after big, intensive, high-severity crown fires, you know, there are, in some of the places we've sampled, there are 300,000 or 400,000 trees per hectare. And what that boils down to, if you want to think of it on something that you can put your mind around, there's about 40 to 50 trees in the area the size of a card table. So the regeneration is just incredible in some of these forests. And so we don't need to do a lot of remediation and replanting. Now, we'll see what happens when we sample this after these timber harvests, and what's going to happen there. So Logan mentioned something about ecological protocols. You know, not sure exactly what you mean by that, but please do feel free to, we're reading through the chat right now, please feel free to email Paul or myself anytime, or give us a call, and be glad to talk to you about this field study with students that you're thinking about doing. We'd love to talk to you about that. And you know, as far as equipment, it's minimal. We're forest ecologists, field ecologists, and we can get by with a minimum of equipment. It's not very expensive, and you know, depending on where you are and when you go, it's, you know, good chance we can loan you some stuff. So please do get a hold of us. We'll talk about that. I don't see any other chats coming through. Anybody else have any? Oh, let's see.
Hi. Oh.
So Mary's asking, will we be using the same techniques at the other sites? The answer is yes, in terms of all of the first set of measurements that I was describing, and Paul's measurements of fuels too. We'll be doing all of those. What we won't be doing probably in the Montana and Idaho sites is the fuel moisture stuff. So we'll be doing all the forest structure, tree heights, diameters, surface fuels, crown base heights, productivity, understory, composition. We'll be doing all those techniques at all the sites, but not the fuel moisture.
Your email here for Logan?
I can get Dan and Paul's email to Logan, and actually I think both Dan and Paul were copied on the message that went out announcing this webinar. But yeah, Logan, I'll make sure you get that.
This is Sylvia. I have a question. You talked about all of this that you do out in the field. I wonder if you could say a little bit about the kind of data analysis and those kinds of things that you do once you're back in the lab.
Sure. Well, initially we'll take all our field data and enter it into spreadsheets and databases, and then we use some pretty straightforward statistical approaches. So if we're doing if you're looking at the effect of some factor, whether it's different harvest types or whatever, then you have some variable that you're interested in. Maybe it's, let's say it's net primary productivity. We'll look at the influences of the different harvest types on productivity, maybe using something like analysis of variance. We may use regression approaches to understand, to make predictions about what those kinds of harvest types might produce in terms of whatever response variable we're interested in. And so we'll use a pretty standard suite of those. We'll of course do a descriptive statistics, looking at means and modes and medians and variance, how much variability we're seeing within the different harvest types. So within lop and scatter, we're expecting, depending on what the pre-forest was like, there may be a lot of variability in what we actually measure out there on the forest floor after the harvest. Plus, then you throw in the variation in who's the person sitting on the machine doing the scattering and the lopping. So that's a human influence that I'm not sure we'll be able to quantify that, but we can certainly quantify the variance within all those sites. And then we'll be using some modeling efforts. There's a widely used model that the Forest Service in particular uses called the Forest Vegetation Simulator, FVS, and it will take a set of initial conditions, which is what we're going to be measuring after these harvests, and then it will grow and develop that forest over whatever period of time you specify, 100 years, 200 years. And then we can take those developed forests and feed that information into fire behavior models. There's a whole range of those. The FVS model has an extension, the fire and fuels extension, that'll actually do it, and there's several other fire behavior models that'll do that. So we'll be taking the data that we collect and plugging them into those models that'll calculate rates of tree growth, rates of recovery of biomass, rates of recovery of carbon storage, and then how that relates to fire behavior and carbon emissions.
That's really helpful.
Go ahead, Sylvia.
Yeah, I'm sorry. It seems to me it's relatively easy for teachers to get involved with, and their students to get involved in going out and doing some of the field data gathering, but that might be more challenging to think about. So now we have all this data, what do we do with it? And whether you guys would entertain some additional help or some working with the team on some studies that they might be doing, which kinds of statistics to use or how to answer the questions that they're interested in doing. So.
Yeah, and maybe an option too would be to do another one of these, into the fall when we've had a chance to enter some data and do some preliminary analyses, and then just share those with you on a webinar, and then whoever's interested in learning more about that, we could, have more sort of one-on-one meetings with those folks.
Yeah, that's great. Thank you.
Yeah, that would be great, Dan. I'd be interested in seeing whether, what kinds of, if you'd be willing to chat with us about what kinds of either statistics or even like graphical representations of data we might be able to work with that could be, accessible to middle and high school students for kind of understanding the research that's going on.
Yeah, a lot of the data, especially when you're talking about things like tree density and average tree height and stuff, high school, middle school students can certainly wrap their heads around that and do some pretty simple, straightforward analyses with that. So we'll be glad to share that with you.
That'd be great. Yeah, maybe we could get some kind of sample data sets that kids could, manipulate themselves and do some interpretation. Do your models? Do you do models for different forest types, I guess?
Yeah, you'll have to, because different forest types. For example, lodgepole, pine are shade intolerant trees, so they don't like shade. They don't do well down deep in the canopy, and they grow rapidly quickly, but once the canopy closes up, they slow down quite a bit because they don't like the shade. And so if you're modeling growth, tree or forest growth in a lodgepole forest versus, say, a spruce forest, spruce like shade, they do very well in the shade. They can maintain higher rates of growth in the shade. So you have to tweak the model and then put in the correct growth parameters, et cetera, for whatever forest species you're using.
So is it fair to say that kind of the implications of your work might inform like which types of treatments might be appropriate in different places, taking into consideration, ecological impacts as the outcome of interest?
Sure, absolutely will. I mean, there's been some work done on post-beetle salvage, but less work done on some of these different treatments that we're interested in. And so we've picked two of the most common, as Paul said, the lop and scatter and whole tree, and we really want to see, if it makes a difference, and then if it makes a difference if you don't harvest it. So it'll definitely, hopefully, will inform, what are the appropriate management techniques.
And so how does that fit in with the whole decision about making alternative fuels? Where does that information enter the decision-making cycle?
I suppose it would depend on what your criteria was for is this feasible. Our data is also going to inform something that the life cycle assessment team is going to be doing. The life cycle assessment is a really big picture assessment of carbon budgets. So it takes into account all the things that we're measuring. So how quickly are these forests taking up carbon? Are they giving off carbon during fires? But they take that, but then they go even further. How much carbon emission is happening from the trucks that are used to haul the material? How much is being emitted by the the feller bunchers that cut the trees? How much is being done is being emitted by the processing plants where the biofuel will be converted into biofuel? So they're looking at a really big carbon picture. And if maybe your criteria was, is this whole process carbon neutral or perhaps even carbon positive? Are we maybe storing a little more carbon than we're giving out? If that's your criteria, we hope will inform that. But maybe your criteria or your objectives are a little smaller scale. Maybe you're just interested in how will it affect productivity on a stand, or how will it affect the economy of a county in Montana, or how will it affect community in some small community somewhere. So I think it depends on what your objective is and what your criteria are.
Well, thank you, Dan and Paul. Let's ask, are there any other questions or comments for Dan and Paul before we sign off?
And Beth, please share our email addresses, and if something occurs to you later on, please drop us a line.
I will do that. Let me just recap before we go, sort of your plans for that you'll likely be working in Colorado earlier in the summer and Montana later in the summer. Is that, did I understand that correctly?
Correct. Yeah, you can probably count on, we won't go north from here until after the end of June.
Okay. So somewhere, it could be early or mid to late July when you'll be in Montana.
I would think we're gonna be heading up there as soon as we can, so probably early July. And until we visit the sites next week, it's unclear to me if we're going to go to Montana first or Idaho first. I can't even tell you that.
Okay.
Because it depends on a lot of things, snowpack and how fast it's melting out, and some of the forests in Idaho are a little lower elevation. They're mixed conifer. Maybe we decide we want to go there first. But we'll know a whole lot more after next week, after we go up there, and we'll be sure to spread that information out when our schedules become more final.
That'll be great. And in Montana, will you be at Lake Lubrecht itself, or also kind of the Helena National Forest and Helmville areas?
We think both, and that may be important for you folks if you want to come join us, because my understanding is Lubrecht has some pretty nice housing options.
It has some places folks can
And
stay.
whereas, if we're out in the Helena, it may be that we're Helmville, we may be camping or something. We don't really know. That's part of the reason for the trip next week is to figure all that stuff out.
Okay. Logan chimed in. He has a family ranch in Helmville.
Oh yeah.
Yeah.
Oh,
he's offering to put you
careful
up.
what you offer there, Logan. There may be 6 or 8 of us. But thanks for the offer. That's very nice.
Yep. Great. Well, thank you so much, Dan and Paul. That was really helpful.
You're very welcome.
You're welcome.